Hello everybody, today we're gonna discuss about Factorial MANOVA in our or two-way MANOVA in our software. In order to do that, the two package, that means the char, mass, and literally later I'll show you the hex plot are important package in order to run the two-way MANOVA in our software. And usually the two-way MANOVA is used when a researcher wishes to investigate whether two or more grouping variable affect two or more response variable. So today we will use the FF data, which is my own data. I already imported to our software in order to save time. Here is the replication. Here is the NPS rate, the one factor, and BS is the Brary sledge, the second factor, and the remaining columns are the response variable. So that first you have to convert the replication and the two factors into factors from what they are. So by checking our structure str, then type this, and our data name is ff. So we will change this replication and replication the NPS rate, that means nitrogen, phosphorus, and sulfur blended fertilizer, and the BS stands for the Brary sledge. They are integer, so we must convert them into factor using the factor, or alternatively we can use by adding as dot in the front of factor. So change this into factor. Then after you have to use attach FF or our data in order to minimize syntax writing over here. If we didn't incorporate this, so we type that as equals to, then what? Our data name is FF. So in order to omit such things from this, you have to use attach FF. And if you want to see the names of our variables, so you have to use the names and FF, so it will display in this way. So here is the module that we create for the multivariate for the two factors. So I give here WAC, then linear module, then you can bind. You have to use the bind function. Then here is the planted, here is the leaf area, here is the days to something. So these are the response variables, and our factor here is the Brary sledge plus the NPS plus the interaction of NPS and the Brary sledge. So -1, I write -1 here to remove the intercept effect. So type this and submit to our studio. Then let's see our summary. Yeah, so our summary is look like this. Here is the Brary sledge, the individual as well as 0, 10, 20 is the level, that means 0, ton, 10 ton, and 20 ton per hectare. And again, here is the NPS is at the rate of 50, 100, and 150 kilogram per hectare. All are statistically significant. And again, coming to the interaction effect, most of the interaction effect is not significant. However, the interaction between Brary sledge at the rate of 20 ton per hectare and NPS fertilizer at the rate of 50 kilogram per hectare is significant. So by this way, we can check the summary and go for to run the MANOVA or the multivariate analysis of variance for two factors. To do that, you have to use the function MANOVA, then indicate what means a linear module that combining the response variable as explained by Brary sledge plus NPS fertilizer and the interaction between NPS fertilizer and Brary sledge. So this represented by all the syntax. Then the multivariate is equals to true, yes, and again the type is equals to 3. Why I do this? There is different type sum squares. For example, if you type is equals to 1, this is especially for the balanced design, that means for equal group observation. Again, if you type 2, that means it's mostly powerful when there is no significant interaction between the two factors. But in our case, and type is equals to 3 means especially when there is a significant interaction between factors, it is advisable for the case of when we have significant interaction between the factors. As you see, here is the peroxide at a rate of 20 ton per hectare, as well as nitrogen NPS fertilizer at the rate of 50 kilogram per hectare. This is statistically significant. So here is the interaction effect. So we may enforce to use type is equals to 3 because the type 3 semi-square is especially uses when we have a significant interaction, and type 2 is most powerful when there is no significant interaction effect between the two factors, and type 1 is preferable when we have a balanced design, what means equal group of observation. And here the test is equal to Wilks. As you remember, there are a number of tests like PLE, like the Hotling, the Roy method. So I select here, and you have to trace back to refer to my previous video for further information. So type is equal to 3, the test is Wilks. So type this and submit to our studio. Yeah, so the berry sledge, the NPS fertilizer, and the interaction effects are highly and statistically significant for the response, for the mentioned response variable. And so moreover, you can add, you can go for the partial ETA squared value for the MANOVA. The partial ETA squared value is mostly explain the portion of total variation from a specific group variable excluding all the other grouping variables. This is commonly used as a measure of the effective size. So effective size is chiefly it is a way to quantify when there is a difference between the two groups. So there are 3 different methods of determining the effective size. The first one is standard mean difference, and the second one is Pearson correlation, and the third one is the ETA square method. So ETA square method or ETA estimation value is divided into 2. The first one is the partial, and the other one is the ETA square value. The partial is recommended when we have more than one predicted variable, while the ETA squared value is recommended when we have a sole or one predictable variable. So partial ETA squared is can be calculated. For example, if we have planted, so the planted effect divided by, that means the planted sum square effect divided by planted sum square effect plus what? The sum square of error included in the that found in the model. But in the case of the ETA squared value, it is the ratio of the planted sum square divided by total sum square. That's the difference. And the partial ETA squared and ETA squared value are similar for one predictor, especially in ANOVA. So we can, in order to do that, you have to use the package, the HEP plots. So type this and submit to our studio. Then you can easily to calculate the ETA squared value for our multivariate analysis of variance. So in order to do that, assign here you have to use the function ETA square, means ETA square, and here is ANOVA. Then write your model. So our model is WAC, and ANOVA is equals to true. So we will get such a result. So on the basis of result, we can say that especially the highest ETA value is especially it ranges from 0 to 1. So the one which is closer, the one that means your value, if your value is closer to 1, it indicates higher proportion of variance that can be explained by a given variable in your model. That means in our case it's WAC, and which is after considering or after accounting for the variance explained by other variables in our models. So in this way, on the basis of our result, so we can conclude, or we can say that the 50 here is 52.13 because it's highest comparing to the 2. So we can say that 52.13 or 14% of the variance of our response variables is due to the difference of what? The PS or the Bray sledge, and followed by the NAPS fertilizer, which is at 42.04, and lastly the interaction of the two is around 39.73. So in this way you can perform a two-way or factorial MANOVA in our software. So this is all about today's tutorial, and if you have any question regarding to my tutorial, you can address me through different methods, either in email or in YouTube comment box. Thank you for watching, and have a nice time.